Hello Tule, I hope you're doing fine. Welcome to this tutorial, and in this session we are going to look at R Shine, and more specifically we're going to look at the introduction to R Shine. I'm Africano Byamugisha, a business scientist who uses R in all his analysis tasks, and I prefer presenting more results using R Shine. I'm very passionate about data science and all evolving technologies, and more particularly in AI and machine learning. If you'd like to connect with me, I'm available on LinkedIn, GitHub, and all other social media platforms on the name of Africano Byamugisha. So, what are we going to look at in this session? This session is going to provide an overview of R Shine and its capabilities. It's going to get you started on building your own R Shine application, and most importantly, it is going to give you tips on how get on your path to becoming an R Shine developer, enable you use it to present your results in a more interactive way. So before we dive into R Shine, could you be interested in getting a detailed breakdown of R? Are you new to R, or maybe more interested in R Shine? You can check out this comprehensive guide. That is some material that I've put up that I keep updating now and then whenever a new thing comes up, whenever one of my people who use the book say maybe they would want this thing to be added, I add it there, so you can check it out. Actually, you can just have a simple look at it. So it is on that link. So it has introduction to R Shine, to R Markdown, generally like an introduction to R, and is a self-study guide. So in case you're new to R, please find the link in the description of this video. You're going to find this book that is kept update every now and then, and today more particularly you might be interested in this section here about R Shine, and it is very well detailed, so you can check it out. So proceeding, what is R Shine to start with? R Shine is a package that was developed by Hadley Wickham, and it is a framework that helps you create web applications in R, and the most important bit of it was built with data scientists in mind, not just for creating web applications for fun, but specifically for data science. So it allows you to create interactive web applications and dashboards using R, fully using R. And the most good part and very interesting bit of it, it enables you to get that power of R. Use your R to write your very good models, visualizations, and in most cases we normally struggle to share work we've done in R to people who are not technical. So here is the solution. R Shine makes it very easy for you to transfer those superpowers of yours of R programming to other people by sharing work with ease. So what do you need? You need R installed on machine. You need R Studio, which is the IDE, in case maybe you use other IDEs well, but the most common one, the most better one I would recommend is R Studio, and then installing the R Shine package. That's enough you would need. R Shine was created in such a way that you don't need very those complex technologies, CSS, HTML, JavaScript, server integration. No, it was built to make it easier for you to create web applications with ease, especially using fully R. However, you might want to bring in some nice things sometimes which are unnecessary, but sometimes to bring in the complexity, and that's when you need HTML, CSS, JavaScript, add on some customization, but it is not needed literally. So why should you even use R in the first place? Why R Shine? Why should you use R Shine? The very good reason is it will allow you to create interactive and dynamic web applications without any knowledge of web development, server integration, or those things. Secondly, R Shine makes you get that ease of sharing your work to other people via web. Every person that can access internet will be able to access your work through a web application. And now this is something that is very important. Shine was built in a modular way that you can customize it to meet your specific needs, even if you want to make that complex website that is presenting your results. Shine is capable for that. You can fully customize it. And what is the big concept here? Simple. Interact, analyze, and then communicate. It's like you're a business scientist in mind. You prepare your data set, analyze it, model it, create these visualizations, and then no suffering, copy paste here in Word, directly share your work through R Shiny. All in R, without getting very many combination of tools. That's the big concept of R Shiny. So here are a few examples of R Shiny that you can come across. Maybe we can look at before we dive into the real stuff of R Shiny. The first one is Parrot TNT. This is an app that, here is the application, very interactive. So for example, maybe you've been running an ad or maybe a campaign on Twitter of people using R Shiny. You want people to start using R Shiny. You're trying to run that campaign, so you want to understand how is it moving currently. So maybe you've been using hashtag Shiny, so you want to search Twitter to see how did it work out. So it is trying to connect to the Twitter API, all that stuff, as it is trying to search around what? Twitter. So check this amazing analysis with ease. So a person who doesn't know about R can use this application. But imagine someone throws to you this code. Could you even use it? Of course no. Then there is this one here. One of the advantages of R Shiny will help you create this application that will convert the hundreds of pages into a simple application that can be shared with ease. Check here, there is a description, rationale, some guide here to check, what are we talking about in this, writing. Then the most good part of it, you share your analysis directly. So whoever is, trying to look at this research, doesn't need, will actually read each and everything because it is in an interactive way. Some, sort of embedding your model that does some calculation, all that stuff. And then this looks nice, right? And this is full R, nothing else. Sometimes we want to bring in that complexity, like this one here. You have to bring in that complexity. So that's when CSS, JavaScript, and HTML come in to bring in these nice stuff. So this customization, you do your R Shiny, you do your R codes, what after, then you create your Shiny app, then you customize it using CSS, JavaScript, and HTML. But this is when you want to bring in complexity. Sometimes because this is great. Check this, and this is also what? This is also great. So these are some of the examples. We can, here are links, we are going to put them in the description, and very, very many more we are going to look at. So without wasting time, let's get into building our own R Shiny application from scratch. What do you need? Of course, we are talking about web. So a web has the UI, the user interface. So the first part of creating an R Shiny application, you start with defining a UI layout. In other words, defining how the user, what the user is going to be seeing. Then from there, of course, you must input something, you must output something from that Shiny application. So we need to define the input and output frames. using different types, as we are going to see. Then from there, we define the server logic. So what is the server logic? Is what is your R code that runs that back end work, that plots the graph, that maybe computes the model, that code of yours that creates maybe a linear regression model, that code that plots a plot. So that's what we put in the server logic. So the server logic creates output, is the one that creates output. And then interact, to get that interaction between the UI and then the server, we use reactive expressions, we use conditional logic to bring in reactivity and interactive behavior, as we are going to see later. And then when you have your app, you use a UI layer with the input and output frames, and then server logic that defines what should happen when a user does this one, and then the interactivity behavior embedded in. Then we deploy. Deploying means that you're getting now your work beyond your local machine to what? Other people that to get, for people to be able to access it. So, having known how the steps we follow to build a Shiny app, what are the key components of an R Shiny application that it should not miss for it to exist? One, the user interface, as we saw, which defines how the application looks and feels. Then the server logic, which defines the behavior of the application, which defines how it responds to input, which defines what should happen to data maybe. And then reactivity. Of course, we are not presenting papers on printed papers. We want this application to be very reactive, to be interactive. So we bring in the interactivity and then the dynamic response by use of reactive programming. And this is no big deal. Just a single line of code will bring in reactive programming. That's the beauty of R Shiny. So R Shiny would need you to have a file structure as any other web application. We have two R Shiny file structures. One is the one file structure where your application is in one file, and that file we name it app.r. All the code that is on your application, that runs your application, is on the app.r, or the two file structure where we have the ui.r and then the server.r. Taking of the spelling, there should be these spellings, UI and then server. And what is the most preferable? Doesn't it sound confusing? If I'm to recommend, and what I normally recommend is using a two file structure. Why do I recommend a two file structure? One of the reasons is you're going to have a user interface. You have the server logic. I think you won't want to put them in one file. You would want a separation of the UI and then the server separately. In case you get an error in the UI, you know that. In case you get an error in the server, you also know that one. And sometimes with time, you're going to start building complex applications. You have this analysis starting from exploratory data analysis to visualization to modeling to forecasting. You want to put all that stuff in the Shiny application, like you send maybe to your manager, or you want to present work on your portfolio like that. So you might you want not have a very long code in one line, like in one app. So you would want to get the UI separate and then the server separated. Also, that one saves you from scrolling up and down. And then another thing is, most of the apps I come along, those complex good apps I come along, I normally see them in a two file structure. So which means that all these professional R Shiny developers prefer using a two file structure. However, this doesn't make any difference in the technically, it doesn't make any difference, but for your programming and your code flow, I would recommend a two-file structure. So we stopped of building a Shiny app and we looked at the components, one which was the UI, and we saw building a Shiny application. We need to define the layout. We need to create input and output. We need to create the server logic. We need to create the interactivity. So let's start straight away by creating what? The UI. By defining the layouts. There are very many types of layouts. You have the sidebar layout, the fluid page, the dashboard page, the grid, the tab, the nav, and very many more that I won't mention here. But let's get into this one practically. We build our app step by step as we learn along. So I'm going to go straight away to R. So this is my R studio. So, and I'm going to use the two-file structure. So the easiest way, just come here on File, create a what? Create a project. So I'm going to create a new project. Then, I didn't save this workspace. So it's going to start launching a new project, as you'll see from here. Then once it launches a new project, I'm going to select Shiny application. Then from selecting a Shiny application, of course I will choose either it is a one-file structure or a two-file structure. And then this might vary depending on the version of RStudio you're using. Sometimes it might not bring you the two-file structure, sometimes it might not. So it's up to you to define which is which. So we're going to create a new project in a new directory, and we are going to use R Shiny application, and let's give it a name, or R study, maybe intro to R. So I'm going to create it here, and so it will create for me, it will prepare for me the working space. As you know, creating a project, it will set for me the working directory. It is going to create for me the project file. It is going to create for me, to set for me the workspace without suffering. So that's what it is doing for me, all that work. In case you want to get more detail about all that, you can check out the intro to R, the guide to R programming. It has all those details in case you're new to R, or you're getting started, or you want maybe to learn more about R. I might have mentioned something maybe you might be interested in. So by default, it is giving me a one-file structure by default. So in case I run this application, for example, let's run the application from here. It's going to run the application, then it's going to launch a viewer where I can view my R Shiny application. This is the default one, the example that comes with the R Shiny project. Once you create that R Shiny project, so it is having a slider that is plotting a histogram. You want maybe 30, maybe 25 beans to create maybe 150. So it is very interactive. So what do I normally do? Easy. I just come here, I delete this app.r. This is the one file structure. But I prefer, and I normally recommend, a two-file structure. So what will I do? I will create a new script, and then I save it as ui.r. I also create another one. I also save it as server.r. So I'm having my two files, ui.r and server.r. So ui.r is going to contain my user interface. definitions. Server.r is going to contain my logic, what defines what should happen when a user selects something. And note that these two files should be in one folder, and no two apps can be in one folder. Each Africano application should be in a separate folder. So that's why you must keep a keen eye on your working folder. So we expect one web application or one Africano application in one. So I must make sure I have one UI and one server in a folder, which is okay now. So let's start with defining our Cheng user interface. The first stage is installing what? Our Cheng, which is just Cheng. The package name is Cheng, and I normally don't prefer this one. I normally prefer going on packages, say install, then to try all the package installation context, and then I install what? The Cheng package. Then after installing the Cheng package, I will define my user interface by starting the layout. And this time let's just use the first one. Let's use the sidebar layout for now. Then you can check out, these are links that will take you to the Cheng guide that shows you how does a dashboard layout, how does a grid layout, how does a tabbed layout look like. So I'm installing Cheng. Why I like this one, I can't mess up with the spelling, I can't mess up with the font, the case, and I can't. There is a disadvantage here. I check install all the dependencies that I might need with Cheng, and then I say install. So from there, I load the library, I load the package using, we all know this one, library Cheng, which is here. So let's define the UI, the layout, and we're going to use the sidebar. So you just say sidebar layout, and then the sidebar layout has two components. The first component is the sidebar panel, and then the second layout, the second part is the main panel. So I'm having the sidebar panel and then the main panel. So I need to also define a blank server that does nothing, and it's just a function. A server is a function of input and output. That's the server. A server is a function of input and output, and that's all. So let's run this application and see how does it look like. We will just define the layout only. So guess we have, yes, it is a blank Cheng application, but it exists somehow. So let's check out now. You would find the layout. You chose the sidebar layout. So we've gotten done with the layout. So how about the inputs? What are the things these are the things we want to input in the application. And here we define their frames where the inputs are going to be inserted into. We are going to define the input frames. So an input can be numeric input, so we use numeric input function. It can be a slider, as we saw. It can be select, it can be a checkbox, it can be a radio button, it can be a date input, it can be file input, password input, and so much, very, very many. And here is the link that contains all the possible Cheng inputs, and we can create them with just a single input, with a single line of code. So let's try out using maybe a select input. So maybe I want to put my stuff here in the in the sidebar. So I want to select input, which is that. Select input. I must mind, the spelling. I understand this must be capital I. Select input. So this one has function calls. So the first function argument is the input the input ID. I must mind about the spelling, the input ID. So the input ID is, this is the unique identifier. So what can we use this one? Maybe we can use, this is going to be, we can say this is going to be, you can call it maybe, input. Maybe we can call it input 1. This is our ID. Then the label. This is what we see on the screen. So the label we can use, maybe select your choice. Then what choice? We need to give it choices. So the choices are, I want to put a vector of choices. Maybe the first choice is choice 1. The second one is choice 2. Let's first put 2 for now. And then let's run our application again and you see how does it look like now. So here is it. We have a selector that gives us choice 1 and then choice 2. But let's do this one in actual, without playing around. Let's create an app using the empty cars dataset. So let's say here you select this, so we can come here on, let's check how does empty cars, this is an inbuilt dataset. So empty cars, if you want to get a data dictionary of a dataset here, we use the help. So once I run that one, it takes me the help, and then I get the data dictionary. So number of cylinders, then display. So maybe here I want to select number of cylinders. Remember, I say my ID is going to be CYL. Then I say, what should the user see? I say select number of cylinders, and then what should this person see? What are the choices? I don't want to type these choices here. We all know this one. We can use the unique function, and then we get empty cars and CYL. And not when these are numbers, so we might, so once we run this application now, so it does, it should not have other, it doesn't know this one about the UI. So here it is fetching all the unique number of cylinders so that we can select them. So that is done. Number of cylinder. Maybe we also want to input someone to be able to select maybe the gears. Maybe we can get a slider input that selects maybe horsepower, the gross horsepower. So easier, we just say slider input. Mindful about the spelling, slider input. So the first argument, I already, during function call, if I know the position of the argument, I don't need to specify its name. I can just put it directly. So I can call this is horsepower, that is my unique ID. Then my label, I can tell this person that select the horsepower. Then arguments vary by input, by function. So here, since this is a slider input, I must have a minimum and then I must have a maximum, because we don't want the slider to be up to infinity. We need the minimum, we need the maximum. So what could be our minimum and maximum here? This is something you can do. What? Maybe I want my minimum to be 0 and my maximum to be maybe 400. No? And what should be the default value? Maybe I can say, if someone is not selecting anything, let it maybe be 10. Fine, let it be 10. Guess there is an error here. UI components are separated by what? By commas. Then this is just an issue of argumentation. So let's run that one and see. Yes, now see we have a slider, and then we have, we have an input that doesn't have a server logic. That's what we have right now. So how can we now put the server logic in? But before we put the server logic, we want, after someone selects, then output should happen, and we want that output to be in the main panel. So now we come inside the main panel, we define the output. So here we've seen these are very many types you can do. What they are actually more than these ones here I've listed, but these are the most common ones. So outputs, how do we define the placeholders for outputs? In case it is a table, we use table output. We use text output if it's text. If it is just you want to output a UI element, if it is data table, verbatim text. So there is a difference between text output and then verbatim text output. This is for formatted text, and then this is for just rendering plain text. Maybe leaflet, there is render.dt, high chart output if you use the high charter package for plotting. So what are the things we would want to output? Maybe one, we want, if someone selects the horsepower and the number of cylinders, maybe we need to plot something. So I come here, you say I want a plot output. So plot output. So that one would mean I expect to get an output. Oh, sorry, I got to edit that. So it will be plot output. So the plot output, it also has a unique ID. Because remember, at the end of the day, we want to link the UI to the server. So I need to give it a unique ID. And I know the unique ID is always my first argument, so I can call it by position. Now we can call a function by position, by argument name, and by index. So here maybe I can call it plot1. I want to plot first value, and then also maybe I want to output a table of so I can say table output. But now, before we go, let's just skip in the future. There is a package called dt. So I can say dt. Let's first skip in let me say table table output, and the table, maybe I can call it table 1. So let's run the application and we see. So it cannot find the function prod output. So what could be the problem here? Of course, I've messed up with the name. In most cases, I think this should be capital O. Yeah, it should be capital O. Cool. So we have our thing working, but with no output. So what if you go and define our server? So in the server, we say the server is the function of input and output. It will get the input, then it will link it to the output. So let's do that. So in the first place, dataset here. On what? On table output. We want to output the whole dataset here. So I come and say input to access a variable in a data frame or in an object in R. We use the dollar symbol. So it has already detected I have 2 inputs there. But this time I don't want any input. I actually want output directly. So output, and guess what? It has already detected that I'm having 2 outputs, a prod and a table. But I want output on a table. So how do we output? So each output has a corresponding rendering function. So this is table output. So if it is a table output, then here I need to come and say this is render table, which is here. So I'm going to output a table. So I put all my expressions here, and what am I doing? I'm just outputting empty cars. For case of illustration, I'm on outputting empty cars. So it is going to get empty cars, and then it's going to output it where? Output it on this location. Let's run the application and see what it does. Guess what? So it knows there is a reserved space for. There is a reserved space for the prod, and then it has plotted the what? The empty cars data set here. So what if we bring in some nice thing? There are very many packages that we can use here. What if I come and I install a package called maybe Git summary? Let's try out Git summary. Git summary helps you to produce publication ready free tables. They are always ready to publish. So let's install that one, and then we can also install DT for working with data tables. Also DT is a good one, so I can use library DT. It is nothing I need to install it. Where would have put a command to do that one for me. So as it is working on installation, so we have our outputs here, which you can explore. And how do we bring in reactivity? Because at the end of the day, we want, if someone chooses the CYL or selects maybe this number of cylinders, something changes. And the whole definition of reactivity is the ability of the application to automatically update when its outputs change, like when its inputs change, sorry. So to add reactivity in a Shiny app, we have about 3 options. The first option is using the default reactivity behavior, which is using the render function. Render output, render prod, render table, render print, render text. That's the default. In most cases it is always enough, but sometimes you want to make it more, advanced. You want to make it more interactive. You want to make it more functional. So we use the observe and the reactive functions. How do they work? The reactive creates an expression that automatically updates itself whenever input changes. Then the observe creates an observer that gets executed when its input changes. For example, a button. If someone presses a button, something changes. So that there we use observe. It keeps observing the button. If someone presses the button, then it executes. But reactive, it creates an expression. It creates like the way we create, for example, if you have an expression to get two roots of an equation, of a quadratic equation, so you create that equation inside the reactive function, and then deploying Shiny apps. Let's first go and add in reactivity to our function here, to our Shiny app, such that we can use reactivity, so that we can deploy it. So if we come here, so now the reason I installed DT. So now let me come here, also library DT. DT gives us a way of outputting tables in a more nice way. So what does that one mean? Instead of saying that like table output, I can say DT table output. That one would be what would be better. Is DT table? No, it actually should be DT output. So yeah, DT output. And let me say this is table what? This is table 2. So I need to create a linking between the server and the what? The UI. So I need to come here, say output, and so it needs to detect a new output dollar symbol. It should be somewhere like table 2, and now I want just the basic reactivity is render DT. Remember, I use it now. I'm no longer using the render table. Now I'm using render DT because my output element here is a DT output. Actually, this should be a character, so it should be in what? In double or single quotes for it to be a character. So, and I'm rendering what? Empty cast still, nothing has changed. But I want us to see the difference and the importance of you to go in and code and to give you now check. And you seeing the difference? This table has a selector. You can select and search for something here. It also has a Shiny loader, as you can check. It is loaded. So this is the difference. So I think we can get rid of this one. We don't need this one now because the other one is actually more interesting. So that is one. So what if now we have one output, but we need to plot? Let's create some plot that is dependent on the empty cars, and then this that is dependent on the number of cylinders, and then the what? The horsepower. Okay, of our application, that can output a very nice table, as you can see from here and then viewer. But we want to bring in that interactivity before we do what? Before we deploy it, because it's like we've not used these inputs we are having here. So we've not totally used them. So maybe for the table we want to output when the depending on the CYL, the number of cylinders. So what do we do? For example, I want coming on the server, I want to output a table that only shows the table that only shows the CY errors selected from here. So what do? It's just normal way. I come here, say, instead of putting the whole table, now filter, but filter by what? I want to say that CYL, you should only print where the CYL is exactly equal to my input. So input and should be exactly equal to input CYL. Let's check whether that one works. See, 6 is selected and we're only having 6 here. Let's come and select maybe 8. See, it is only outputting 8 elements, only 14 entries. So that is what. So let's also run the plot here. We see there is a space reserved for the plot because we did that from here in the what? We have a plot output here. So maybe let's use ggplot too. So not that I'm using DT, so I need to come somewhere here. I say DT is empty cars instead of using the original empty cars dataset. So I'm having DT, I first assign it to empty. I get empty cars, assign it to an object DT. So I want to come, I plot ggplot the aesthetics X, maybe I want to plot AM on the X, whether it is automatic or not. Then on the Y, I want to plot on the Y, I want to plot horsepower, and that would be what? That would be actually a column graph. So geom what? Geom column. So let's plot that one. We need to plot? No, it is not finding geom core. So somehow we're supposed to have, a name that it knows. Is it geom? Let me load the package from here. Let me just load the package, and then so that I can just use the auto completion. It should be geom. I started design. So once I run that up, it is okay. This is not informative. I think a box plot would do us a good would make more sense from here. So if I load that one, cool. You have a what? But not that I don't want, I want it to be as a factor. So I want to first get dt am, I want first forwards it explicitly to a character variable, but which is factor. So that once I load the app, nice. See, this is, at least this is more informative. Maybe I can actually fill, by what? By am, so it becomes more nice and cool. So we have our two, but now this plot we want it to change. Once I say this one, it also changes. So I want to change horsepower, then also the horsepower value changes. What does that one mean? I need to edit somewhere here. Maybe I need to come, I first create a new data set, maybe which is in DT. But why do I need to create it? Let me just filter, pipe it down. So I want to say filter out HP when it is greater than or equal to input. I want to only plot for a greater value, a bigger value, or maybe less than or equal to, it makes more sense actually. Less than or equal to input and HP. So it is going to pick this input here of the HP. Remember, these are the unique IDs here. We call it HP, not that one. So after filtering out, pipe the data down to what? To ggplot. Just do a little bit of indentation for our code to be nice and readable. So equals to, yeah. So once I run that one, so here we almost have nothing, because let's increase, yeah, it is making more sense. Let's increase, see, it is interactive. So we have a prod. So not something here. Here in render, I don't have these brackets here, but here I have them. In the server, the moment you want to have more than like separate codes, like codes that are disjointed, not lines, because here these are more than one line, but I don't have it because code is flowing. But here, this code is disjointed with this one. I need to put them in a block. So this is a block. Unlike the UI, in the UI I separate them by commas, not I separate them by what? Different UI elements. I separate them by commas. This is a different UI element. There is a comma. This is another UI element. There is before the last one. Don't need to put a comma. So we have a nice application. Let me just expand it and see how does it actually look like. So here is our application, which is of course running from the local the local host. So this is how, just say maybe here you want around 240, this printing one 380. See, this is nice. If I come, I want 8, that's that one for my own. See, this is just basic, but now this we can only access this one on our what? On our machines only. But we want we won't share this work to some other people, but who don't need to run anything in R we've been doing. So we have very many different types of sharing a Shiny app. Of course, you have two options. The first option is you share the code to a friend or the whole R script, maybe using GitHub or what, and they run for themselves. But that is for people who know how to use R and maybe want someone to review the code for you. First, you have to share the code. But what are we interested in? To share a link. There are very many options you have. You have web servers. There is AWS. There is Microsoft as well. There is Heroku. There is very many. But there is shinyapps.io. There is Shiny Connect. There are very many. But Shiny also made it more easier for us that they created a free web server that we can host our Shiny applications with ease. No server configuration issue here. This is the most convenient option. However, if you have your own server, you can go ahead to learn about server configuration and then using the CRS upload, all that stuff, and you'll be able to do what? To upload your application there and you deploy it from there. But in this session, and I would recommend shinyapps.io, and we deploy using the RS Connect package. How do we upload? How do we deploy our application? Very easy. The first stage is you go to shinyapps.io and you create an account there. shinyapps.io. So let me load mine here as it is loading. So when it finishes, when you create an account, they give you what we call a token. So a token, very easy, you just come here. You just come on this one. You say publish. This icon is for publishing. So it is going to launch. It first checks where I'm having RS Connect installed. If it is not installed, then it's going to install the RS Connect from me. So it has noticed that I don't have it installed. So I need to say yes, because so that we can install the RS Connect. So here is the R Shiny the shineapps.io. Just click sign up. So on sign up, the normal way is put in your email, your login, your password, all that stuff, and then you create an account, which you can do. This is just an easier prompt. But for me, I'm just going to log in while I already have an account there. So when it comes in, I'm going to just directly do what? Directly log in. I want to create an account because I already have an account already existing. But for you, you would want to create what? You would want to create an account there. So let's log in. So here I'm assuming you've been able to create an account. If you fail to create an account, we saw the book of guide, this book here. There is a whole bunch of material to guide you through, so you can check it out under the section of Shiny. So this is my email, which I use it to sign up, and then my password. And then I log in. Oh, what I might have, I must have missed with 1 or 2 strings. Yeah, true, I had. So now it logs in. So when it logs in, this is the dashboard. We've worked with things of this kind. These are some of the apps that I'm having running currently. It shows I'm having 3 apps. This is for practice, this is the enterprise, this is for shiny widgets, like that. So you just go on account, go on tokens here, because we want a token that will help us publish this application we're going to publish. So once you go on tokens, it's going to open up a new window and we create new tokens. So you just come here, you say add token. So the moment you select add token, don't want to delete my token. So it creates for you a new token. So once it creates for you a new token, just say show, just easy like that. It's going to open up a window that shows you a token, and then again we want the secret. You see, the secret is hidden from here, and not select R. The secret is hidden. You say show secret, and then copy the clipboard. See, you copy all this stuff. You remember copy. Sometimes it doesn't. Yeah, okay. Make sure you copy. You can double check to copy for the second time. So you get the things you've copied, and then you come back in R. So cool, it is showing packages have been successfully installed. So I just need to come here on this button. I say publish application. So once I say publish application, it gives me very many options, but I don't want this option here. I want the shiny apps option, the shinyapps.io. So I just, so now this is the publish to server interface. It has already fetched for me all the files that it thinks that I need for my application to work, and then it is asking me for an account. There is no account created yet. So what do? Just need to come and say add new account. When I say add new account, then I need to select which server am I using. I'm using the shinyapps.io. So it is giving me instructions which you've already gotten. So I get my token, I copy, I paste it here, and then I say connect account, as easy as that one. So it is trying to work on the server configuration stuff on my behalf, as it is trying to connect. Cool, my account is here, it has given it a name. I can maintain the name, then I say publish. So you can monitor the publication job from the deploy window here. See, preparing to deploy, that is done. It is uploading the bundle of application. This is still undergoing. It takes around a minute. So we need to be patient with it because it takes around a minute. Yeah, so as it is deploying, how can we customize our applications? We've deployed an application as we are going to. How can we customize? We have very many options at our hand. We can customize using HTML, CSS, and JavaScript. We can customize using adding user authentications and security features. We can incorporate external data sources using databases, using APIs. If you saw the TNT, the Tap into Twitter application, that one uses the Twitter API to fetch feed directly from Twitter. You can use custom widgets using Java, like you can create your own widgets using HTML and JavaScript. And also, what I've not mentioned is 50 extensions that help you to bring in that more complexity you would wish to bring to the application. So what are the best practices that I do recommend? Keep the application simple and easy to use. Don't make it too complex. Because remember, at the end of the day, you are targeting a non-technical person. In the preceding series, we are going to look at how to optimize performance of the applications. You should first test whether the application runs before you deploy it. Keep the application up to date in case you update some code, you redeploy, because once you redeploy, it actually updates the code. The application, then please document your application so that for future reference you don't struggle. So what are you waiting for? The practice should actually start right now. Any of these ones, and any comment in form of comments in the channel here, in the messages, in the comments, and trust me, you'll get a reply. And also endeavor to use the guide to R programming. Why? Because it actually has there is this section here, in case you don't find what you want. There is a bunch of very many additional resources you can visit. So I think our application must have loaded and launched. Cool, which is actually here. So it has created for us a link. Actually, you can copy this link. Maybe I take it this side of maybe I can open it from Chrome, maybe, if it is my preferable. Assume someone has shared it to me. Yeah, so the moment it finishes uploading, like it gives you a link which you can actually come on your shinyapps.io account and you check it out. You will find this okay, and then go on applications, and I say check. It is telling us actually there is a new app called Intro R, and I can open it in a new web. And then here it gives me a URL that I can share to people. Let's open it by just forcing me a click. Here is our application. So it is saying it can't put 20, it's less than 10. Maybe let me put it 320. Very amazing, interactive. Maybe it is currently plotting for 6. Now I want to choose an 8 here. Very impressive. So please take it on, try to practice. It all gets better with practice. Meet you in the coming sessions about R Shiny in the advanced series, because we continue updating this channel with continuous videos on continuous series. All the best. See you then. Bye.